In this video, we are going to look at the properties of quadrilaterals. Using GeoGebra, we can add to these quadrilaterals that have already been created. So we have a square, a rectangle. Now technically a square is a type of rectangle because it has opposite sides that are equal, 90-degree angles in the corners, and opposite sides are parallel. It's just a special rectangle where all the sides are also equal. Parallelogram, rhombus. So similar to how a square is a rectangle, a rhombus is a type of parallelogram where all the sides are equal. A trapezoid. This is a special trapezoid. Trapezoids in general just need to have one pair of opposite sides being parallel. This one also has opposite sides over here that are equal. So this one's called an isosceles trapezoid, similar to an isosceles triangle where there's two sides that are equal. And finally, a kite. So we can use GeoGebra to do some work for us. We can draw a diagonal by picking the line segment tool, clicking on the point A and clicking on the point C. So now we can see the diagonal for the square. We can click on B and click on D and make a diagonal there as well. Now the diagonals here are quite interesting. It looks like they go through the middle of each other. When you go through the middle of a line, it's called bisecting the line. So we can say line AC bisects line BD, and line BD bisects line AC. So both of the diagonals here bisect each other, goes through the middle. Now if you don't trust your eyes, there's some more technical things you can do to make sure it's actually right in the middle and really does bisect it. So one thing you could do is you could look at the grid system here. This goes down 1 over 1, it's like one diagonal, and this is also one diagonal. So AC is split right in the middle because we have one diagonal on this side, one diagonal on that side. You could also use some tools that are in here. You could draw a special point, you could draw a midpoint. So if you click on the ends of the line segment, A and C, it will put the midpoint in for you. And look how the midpoint, well, AD goes through it. AD must bisect AC. It splits it right in half. Now it's pretty clear that AC is equal in length to BD. If you don't trust me, and if you want to be more exact, like we usually want to be in mathematics, then we can use a tool to measure. Now if this is on paper or if you have a ruler, you could just take your ruler and you could measure it. I could also say that this is 2 diagonal lengths and that's 2 diagonal lengths, therefore they're equal. Or we can use this tool. So this tool is going to measure the distance between the points when we click on each point. So AC is equal to 2.83 centimeters. Now that's kind of in the way, so I'm going to use the pointer tool and I'm going to try to pull it up here. So A to C is 2.83 centimeters. Let's go back to measuring the length. Let's see if BD is equal. It is. BD is also 2.83. So the diagonals here are equal and the diagonals bisect each other. So that's 2 important things about the diagonals of a square. There's one more important thing. It's about the angles. Have you guessed it yet? We could say that the angle here is 90 degrees. It's fairly clear because this is taking up one little piece of the corner, one half the corner. Half a corner would be 45 degrees. The other half the corner, another 45 degrees. So it looks like it's 90. But if you want to be exact, you could get out your protractor, which is the tool for measuring angles. It's like a half circle. And if it's clear, you could put it right up to this and make sure it's 90 degrees. If you don't have a protractor, or if you just want to use the tools that are available here, let's look through and see what tools we have for measuring angles. Well, this is the measuring tool. We used it to measure the length. Now we can use it to measure the angle. So I'm going to click on the start, the middle, and the end. And look, when I did this, it gave me the outside part of the angle. I actually wanted the inside part of the angle, so I could either delete that and start again. Okay, so I'm going to start on this side this time. Look, it drew it for us. 90-degree angle. And you could do it for all these points, and you'll see that it's always a 90-degree angle. Another way that you could use this tool, instead of using it to measure between the points, do they have one that measures between lines? Maybe not. I was thinking one would measure between lines, but we don't need that. Okay, so the rectangle is very similar. You can do the rectangle on your own. You might be wondering, what are you expected to do with this? So in your notes, you have a form like this, and you're asked to draw and label the shape and say some things about the diagonal. Let's see if I can get this a little bit bigger. Okay. So for the square, what can we say about the diagonals of the square? Draw them in. They go through the middles of each other. Oops. So we know this is equal to this, is equal to this, is equal to this. How do we know that those are all equal? Well, we could use the measuring tool just to be sure here, but notice how this is the same length as this. You don't trust me? It's always good to be careful in math. Let's just make sure that piece is 1.41. So from B to the center is 1.41. Notice that's not exact. That was 2.83, so I would have expected 1.415 because the 1 and 5 together would make like 1.5 and 1.5 would make 3. But it's hard for a computer to be exact. It has to round to a certain number of decimal places. From here to here. Okay, so now we can see for sure by measuring it that the diagonals are split into half and that they're equal. And you could also just keep going like crazy and do a whole bunch of measuring. Okay, so hopefully you're convinced. Okay, so we saw that it's a 90-degree angle in the middle, and those would be the important parts. So what can we say about the diagonal lengths? We can say that they bisect each other. And we can also say that the diagonals are equal. Okay, the diagonal angles, well, it's always a 90-degree angle. Alright, now let's look at a different shape. Let's do this trapezoid down here because it's going to be a little bit different than the other ones. So let's start by drawing the diagonals. Remember that I went to the line segment. Now it remembers that I had chosen segment earlier. If you accidentally did this line instead, you would just get a big long line going all the way through. And if you don't like that and you don't want it, you can just right click, delete, and switch it to the one you actually want. Okay, so we're curious, are these diagonals equal to each other? Well, let's use our handy dandy measuring tool. And let's measure R to T. Okay, hard to see the way they piled up on each other, but that's okay. We can pull them out a little bit. Okay, so 4.47, 4.47. Indeed, the diagonals are equal. So on our page down here, we can find the trapezoid, the isosceles trapezoid, and we can say the first one was about the diagonal lengths here, or it's actually the third column. So we can say that the diagonals are equal. Okay. The other thing we're wondering is, do they bisect each other? Do they go through the center point? Do they break each other up into two pieces? Bi means two, like bicycle means two wheels. So bi means two, and sect is like to split, so split into two pieces. That's pretty much where it comes from. My Latin is not perfect. I don't know if it's Latin or Greek. All math comes basically from, a lot of it from Latin and Greek terminology. So if someone studied Latin, maybe they can correct me on it. So does it go through the middle? Well, it would be really handy if we knew where the middle was, so we can add the midpoint. So no, it doesn't go through the middle. Not sure about the other side. Let's check the other one. And no, it doesn't go through the middle. Notice we could also use our graph paper here, our grid, to help us. From R, if we go down 1 over 2, down 1 over 2, the midpoint has to be right there, so we can clearly see that it doesn't go through. But notice that when it does cross, it has split it up so this piece up here and this piece up here are equal, and this piece down here and this piece down there are equal. Now, if it's not so clear, let me show you. So when these two lines cross each other, when they bisect, they don't bisect. Bisect would mean crossing each other into an exact amount on either side. So that's not the term I want to use. When they intersect is the term I want to use. So when they intersect, let's see if we have an intersecting tool. Right here, intersect. So when this line intersects this line, it does so right here at this new point they made for us. And let's show that these two pieces up here are equal. We're going to measure a distance. Okay, and now we're going to measure this distance up to the point S. So from R to the middle is 1.67 centimeters. Oops, we don't want to take that point away. And from the middle to S is 1.68 centimeters. So these two pieces up here are equal. The bottom two pieces you can show are also equal. Now what about how they intersect? Do they intersect at a 90-degree angle? Are they perpendicular to each other? Doesn't look like it, does it? If you don't trust your eyes, sometimes with an example it might look like it could. So it's always good to be exact. If you have a protractor, you could measure it. Or here, we can use our angle measuring tool. And it's 127-ish degrees, 126.87, so about 127 degrees. So it's not a 90-degree angle. Now notice that if I was given a bad example, it's possible maybe they could have crossed at 90 degrees. Maybe if I pull this up. Do you think it would cross at 90 degrees and still be a trapezoid? Trying to pull it together, trying to make it cross at 90 degrees. Well, look when it crosses at 90 degrees, when it's a square. So if it was an isosceles trapezoid and not a square, then it wouldn't cross at a 90-degree angle. But notice how had I been given a trapezoid that was starting to get close to a square, it may have been hard to tell just by looking at it, so it's good to be able to measure it. Okay, so now you can continue to play with the rectangle, the parallelogram, and the rhombus, and the kite, and continue to fill in this table on your own. Let's just finish filling in the trapezoid together. So the trapezoid, we saw that the diagonals were equal, and did they bisect each other? No, not bisecting. They intersect, but they don't bisect, because that means exactly in half. They don't cut each other exactly in half. And the angle was not 90 degrees. So continue to go through and figure out if the diagonals are equal, if they bisect each other, and if the angle is a 90-degree angle.